how you read a little bit of this stuff. Most of these things aren't any different than, for one like this, all it is an area of a shaded region problem with an extra step. Okay, if you start thinking it that way. So what they're trying to do is they're trying to take the original parking lot and double it. Okay? So what we need to do first of all is figure out what's the area of the original parking lot. Well, the original parking lot, when you look at this, it's defined by the school and the parking lot. Take out the school. Okay? So you've got a rectangle, subtract the smaller rectangle. Okay? So if I do that, I know that the overall dimension from here to here was 375. And then from here to here was was it 240, I believe. Okay? So to get the area of the lot itself then, I take that and I subtract just the school area, and I think you get 4,500. When you map all that, okay? Now, that's the area of that lot, and if I wanted to double, I'm basically just adding another 4,500, okay? So what we do is, we know that we want, thanks. What happens here is, we need to get this area, which is the new lot area, subtract out all of this. We need this to equal 4,500. Okay? So we know that our answer has to be 40,500. And to get to that, what we do is we find the area of the shaded region. So we've got the large space, which is our 375 plus an x, and 240 minus an x. And then to that, we have to subtract out this whole space now in the middle. We got to get rid of all of this. And that was that 375 by 240. Thank you. Back out to 90,000. So from here now, what we have to do is make a decision on how much more mathing we want to do. Me, I'm done. Peace out. I'm fine. See what I did there? I was saying I was done. Just joking. At this point, I'm going to use my calculator. I don't have to FOIL anything. I don't have to do anything, because if this works cleanly, I should be able to find somewhere in my table 40,500 for a value if I get a 0. Okay? So that's basically what you're looking at. You're trying to find some 0 value that gets you to 40,500. If I FOILed all this out, I get a positive a squared value, and I graph it and do all that. I can do all of this work, but there's no reason to. So I go to my calculator, and I'm typing in my equation, which was parentheses 375 plus x, close, open, 240 plus x, close, minus 90,000. And what I'm going to do is I'm going to use my table. I'm going to search through my table to see if somewhere along the lines it runs into 40,500. And it does. And I'm looking for positive values of x because I don't care about the negative zeros. It's not going to help me any. I think if you go through all this stuff, I want to say it's at 60.
Yeah, it's more like that.
At 60. Okay. Did you see what button I just pressed? Table set? Okay. Right now, are all of your tables right around 60 as you're looking at it? Instead of scrolling all the way back up to 0, if you hit the button that says second window, and it says table setup, I can change where my table is at. I can change it to 0, and then just go right back. It's easier to start to go back to the origin. Okay. It's just a little shortcut. And that's how that one works. That's how you map that one. All right? Not terrible, was it? 97. Did you figure out 97 with the mural? it's kind of the same thing, but instead of building outward, you're cutting inward. Okay? You're going inward instead of outward on that one. So here you've got the building. The building is 50 by 30. And you want to do is put on that building, the 50 by 30 building, 25% of that area designated as the border. So we know that we want to get the border in here. I wanted that to be 25%. Yes, sir. Yeah, because it says of uniform width. Border of uniform width on that one. Okay. By the time you get here. Yeah. So we know that the overall dimension was 50 by 30. And we have this border of uniform width. So you're cutting inward. So instead of this being 50 now, I got to cut out the 2x. That's the difference. Because it's smaller than what the other one was. The other one we were building outward, we were adding border to it. Here we're making the border inside it. Does that make sense on how that works with the minus? And the same idea here, you get 30. And then it said that you wanted the border to equal 20 or 25% of what the actual area is. So, yeah, yep. So 25% of 1500. And it was 375. Okay. Now, they're asking you to figure out the border. So the border is the shaded region that we have to do. We need to get that area equal to 375. So in order to get that, we have to take, move this up a bit here. So to get to 375, we have to take that large shape, subtract out our quadratic. Okay? That's what that would look like. And once again, would I try to map all of that? Nope. I start searching for zeros. What's wrong?
That's the best way to do it.
Yeah, most of these are going to clean values, so it shouldn't be too terrible. You obviously want the positive value of 0. If you FOILed that out, you'd get 4x squared, so you know that your a value would have to be positive, and then just moving some stuff around it. It's not the worst problem in the world. It's just instead of adding, we're subtracting. 98, I swear it's missing a part of the picture, so don't worry about that one. We did 99. How'd you guys do with the digital camera one? Sales figure one?
Yeah.
You all right on that one? Let's just walk it just in case. Remember, anytime you have sales figure ones where they're talking about unit sales and prices increasing, decreasing, things like that, I want you to automatically, as soon as you read it, set it up so that way you can do intercept form. We have units, how many you're selling, and at the price. Follow that generic idea of a rule, and everything will be cool. But don't drool, or you'll look like a fool. That's cool. What?
Nothing. I just have a friend.
Oh, I'm sorry.
No. It was just,
Anyway, so we sell 70 of them at $680 a pop. Okay. They say then for every decrease in $20, you'll sell 5 more. So for every decrease of $20, that's where the X represents the number of times it's decreasing. you get the number of times it's going to increase over there. Okay? Now from here, it's very fast intercept. We know the zeros are really easy to get. We have zeros, one's positive, one's negative. On that one, it's negative 14. And over here, you get positive 34. What's halfway between negative 14 and positive 34? 10. Error 5. I set these both equal to 0. 70 divided by negative 5. 680 divided by positive 20. So you have an axis of symmetry at 10. Hey, what happens at the axis of symmetry? The vertex. The vertex has an x-coordinate of 10, which means that has to be its maximum. Right? That has to be the maximum because it's. If you FOILed that out, you have one positive x, one negative x, means it's going to be a negative a squared. So it's a max. So your multiplier is 10. Okay? How many times do you have to decrease it by 20 bucks? 10 times. So my sales price that I'm selling them at would be 680, subtract 20 times 10. So that means I have to sell them for $480. At a sales price of $480, I will sell all 70, and I'm 5 times the number of times I've decreased, times 10. I will sell a total of 120 cameras. Now, the Y value in your vertex is giving you the revenue. The Y value gives you the revenue. The X value tells you how many times you have to multiply, the multiplier is. So the Y value here would be your 480 times your 120, which is how much? 76,000? 56,000. That number. 57,600. Good morning. The 10? Axis of symmetry. What's happening between negative 14 and 34? So what's negative 14 plus 34? 20. What's that? Negative. Yeah. It's negative, that's why. Negative 14 plus 34 is 20. You grab the negatives. What's that? The Y max? All I'm doing is I can take, when you get the, if you put this in the calculator, if you find the maximum, it'll be at 10 comma, whatever these two numbers multiplied together. That's your actual value. Sure. Okay, that's one way of doing it. But remember, that value of 10 is representing the number of times it's increasing or decreasing. Okay, I want to make sure you guys remember that, because a lot of times students forget what that represents. But are you whining about it? She whines a lot, doesn't she? You do. Now she's going to turn red. You're talking to her. There it goes. Big Bertha. Did you guys get like 70 miles-ish? Okay. Yeah, somewhere in that neighborhood. So if you had that Big Bertha cannon here, and we shot it, it would hit Lake Michigan.
Whoa.
What? No.
Yeah. If you shoot it towards Chicago, it's going to land in Lake Michigan. That's east, right?
For like 60 miles. Wait, this wasn't one of the German rail car guns.
No, that's different. This one was
Because the Germans built even bigger guns that were on the railroads.
Yep.
Round shell things.
The rest of these were pretty decent. Was there? I'm not really worried so much about the parameter one. Did you guys get Did you guys try the firefighting one? You know what it's asking you there? What's weird about that is when you look at the firefighting one, and this will be the last one I want to do because I want to get into something else here real quick today. Let's do it.
Okay.
So what's happening here is you've got a curve that's down like a frown because your A value is negative. Everybody okay with that? Now, this curve has a C value. Okay? That curve, there are two different heights or two different distances you can be away that you can get to the window that's 25 feet up. Okay? That's what they're looking at here, where the X value here is horizontal distance, and then your height value, your Y value is your height. So what you're looking at is if there's something that's 25 feet up in the air, there are two separate values of how far away you can be. Okay? That's what that means. I'm sure you guys have all had a garden hose before, right? You spray the garden hose up, then it comes back down. So if, what's that? Yeah. Our old dog, we had. I swear I had the only black lab in existence that hated water. Oh, they don't like water either?
No, she hates. Like, take her upstairs, get in the bath, she's dragging her pond to like not go.
Yeah, she would never get it. She would never go swimming. She wouldn't do anything like that. I'm like, you're a lab. You hunt. Oh, maybe that's yeah. That's not good for a dog. I'm not a veterinarian, but it's not good for dogs either. Our old dog, she loved carrots. I cut carrots all the time. You guys see me in the afternoon. I'm always snacking on carrots. Our old dog used to eat carrots like crazy. Anyway, but our new dog, she loves the water. She swims. She jumps in there. She goes crazy. She likes to perch herself on top of our kayak and balance when we go kayaking. It's pretty fun. Anyway, so the reason why this works is you've got two different values because the hose can go here. So all you're doing is if you graph this one in your calculator, then graph y equals 25, you get two different intercepts. That's what that looks like. I want to make sure you guys can visualize what that looks like. If you visualize it, mapping it becomes easy because then you're just plugging and chugging. Okay? What's that? Was there any other in here that was horrible, scary, bad before I go into do something new? Because we'll do more of these word problems as we get into the last few things. I wanted to start into this 5, 3, 5, 4 stuff today. So let's take a look. Oh, wrong class. I have too many files on my computer. Too many files to do that. Depends what chapter it is. Simplifying quadratics and the square roots and the things, and guess what doesn't exist? No, your life exists. You're here. Yours the awareness. We do not use decimals, ladies and gentlemen. That's what I'm getting at. What we use here is called simplified radical form. We use exact answers. So, as a reminder, when you are simplifying square roots, you make them into a little tree thing, correct? What are you doing?
Looking for perfect square.
You're looking for perfect squares. You're right with the whole prime factorization thing. That is correct. But instead of doing primes, we're trying to factor in terms of perfect squares. So you sit there and think, what's the largest value that's a perfect square besides staring at our phone? Put it away. You get 6 times 4. You have the roots, root 4, root 6. What's the square root of 4? So you wrote that as 2 root 6. Does that vaguely ring a bell?
Wow.
Should. You did it. All right. Oh, well, you're welcome. Thank you. I didn't know that there was different ways of doing that. That's just the easiest. That's the way that I've always done it. Why?
I don't.
It's stupid.
I know because then you just
Right, because then you're doing all that with your primes. No, You're sufficient for the big one first. Okay. Now, there is one way. You guys all know that on your calculator, it does not do the square root of 24 into a nice value, correct?
Yeah.
Okay. So there is a way for you to search for them, and I'll show you. If you go to your y equals, and we'll use 24 as our example. What I'd like you to do is type in 24 divided by x squared. No. Go to your table. I want to go to the table. Well, why is that an error at 0? Think about what the table's doing. It's divided by 0. It's taking 24 dividing by these values of x. So 24 divided by 0 squared, you can't divide by 0, that's why it's an error. What's 24 divided by 1 squared? 24. 24 divided by 2 squared? 6. 24 by 3 squared? So on and so on. So what it's doing here is, as it goes through these values, you're looking for the column that has a whole number involved, the x and y, before everything goes decimals. And your answer is 2 root 6. Yes, sir. Yes, and it works for cube roots, fourth roots, fifth roots. Anything, you're just changing the degree by which you're dividing. Do 108. Y equals, clear it out, type in 108 divided by x squared. And once again, go to your table. What's the last value prior to going all decimals? So your answer is 6 root 3. Yes, sir.
I just typed in 24 divided by x squared by and it gave me 8/3 as an answer, and I don't know if it's giving me an answer.
I don't know what it's doing there. Good luck. That's why I told you use the 84. Use the 84.
Totally fine. I've never seen this before. I must have used that x equals.
But I know you know how to do it.
Yeah.
But
That's what
okay. Does that make sense? It's a nice shortcut. Okay? Well, there'll be times you use calculator, times you don't. You should know most of your simplifying rings.
You think.
All right. What about this? How do you simplify that?
You
Multiply by what? 2. 2? Square root of 2. So what this means here is this. Square root 7 divided by square root of 2. It means the same thing. What we're doing here is we are rationalizing the denominator. You are not allowed to have radicals in the denominator. Yes, sir. Yes, sir. Because what's root 2 divided by root 2? Which is it? 1. 1. All you're doing here, and if you multiply anything by 1, do you actually change it? No. No. All we're doing is we're multiplying by some value of 1 so that it doesn't change the problem. It just eliminates the ugliness. All right? What's the square root of junk times the square root of junk? Junk. And you're done. Okay? You are rationalizing the denominator. Now, what about this? It's not as clean, is it? No. How many terms are in my denominator? 2. 2. So, let me ask you this. If I had a difference of squares, if you had difference of squares and you factored it, let's say we had x squared minus 16. Remember why I put those on the skill check the other day? Well, one of the reasons why I put it on the skill check the other day is so that way when we come to stuff like this, you'll remember the idea behind why it works. Is that a perfect square? Is 16 a perfect square?
Yeah.
Is that a subtraction symbol?
Yes.
Did you answer yes to all 3 questions?
Yes.
Okay, so your terms then are x minus 4, x plus 4. So in this case here, you wind up with what's called difference of squares. Now, if you FOILed that out, you'd get x squared plus 4x minus 4x minus 16. Now, if you do that, you wind up with no middle term, right? So, the idea here is I want to figure out some way of multiplying that denominator to get rid of the middle term. So instead of multiplying it by, if I have the 1 plus root 2, I'm going to create a difference of squares by multiplying it by 1 minus root 2. Okay? If I do that, what has to be in the numerator? Exactly. It's got to be the same thing, because 1 minus the square root of 2 divided by 1 minus the square root of 2 is still 1. It just looks ugly. Okay? Now, that denominator here is just a binomial. I have to FOIL it just like I did this. So I FOIL that, I get, move this up there here. If I FOIL this, I'm going to get first 1 outside minus root 2, inside plus root 2, and last minus root 2 quantity squared. Correct? What happened to my middle term? Sayonara, sucker. And what's the square root of junk squared?
2.
Junk. So this becomes 1 minus 2, which is
-1.
and then in the numerator, I wind up with 3 times the quantity 1 minus root 2, which is 3 minus 3 root 2 all over -1. And obviously I can play with my signs and do all that, but I got rid of the radical in the denominator then. And that's okay. Math etiquette allows for radicals in the numerator. Math etiquette does not allow for radicals in the denominator. It's just the way that it's a standardized form. It's a standard way of doing them. I do know that I always in Algebra 2 pre-calc, we always do rationalization stuff, always, because it's how it always goes. When Fontana does some of the AP calc stuff, it starts to become a little bit more of the calculator driven, and it's not as necessary to do that. So that's where the only differences go. Anything that we do for like standardized tests, finals, anything that has multiple choice to it, always goes to this simplified radical form like this. Nothing is left unrationalized. I don't know if that's a word, but nothing is unrationalized. Yeah, nothing is left like that. Okay. So the reason why I was showing all this is because today we're going to start doing stuff like this. Okay? Solve. 2x squared plus 1 is 17. Well, ooh, careful getting ahead of yourself here. So when you're solving equations, you guys all know that you're doing PEMDAS in reverse, right? Okay. For some odd reason, first hour didn't know that. You're like, what? You work backwards from the order of operations. I can't take care of the exponent until I move everything else away from it. Okay. I was flabbergasted. That's so first thing you guys did, you subtract 1, okay? 2x squared, 16. Then what? You get x squared is 8. How do you undo squaring? Square root. Now, when you take a square root, what you're asking yourself is, what are the two numbers that are multiplied together that are the same that give you 8? 2 and 4 are different. 2 root. So your answer was, you guys all know the square root of 8. It's 2 root 2, right? What other number is it?
2.
No. 4 times 4 is not 8.
2.82?
No.
Well, that is a square root.
Knuckleheads.
Are you saying we're knuckleheads, or is it
Yes.
tactical knuckleheads?
This is a big giant knucklehead problem here. Oh, no. So let's see. What's 5 times 5?
25.
Okay. Those numbers were the same, right? Therefore, the square root of 25 is 5. Okay. What's negative 5 times negative 5. Correct. Oh! Remember, whenever you take a square root, anytime you take a square root over an equal sign, anytime it's a square root over an equal sign, there's always a plus minus. So your answer would have been x equals plus or minus 2 root 2. Okay? Now, if you're simplifying a square root, if this was just the square root of 25 and I had to simplify it in a problem, it would just be 5. But at the minute I'm taking the square root over an equal sign, I have to do plus minus. Otherwise, it's wrong. Yes, sir? Great conversation. I'm so happy we had it. Thank you. All right, now what?
Multiply by 3, I guess.
Good, I'm glad you didn't say distribute. Oh, I heard that this morning. I swear those guys, they just weren't awake this morning. So
x plus 5 squared is equal to 21.
good. First thing you got to do here is just get rid of the fraction. To undo multiplying by a fraction, you multiply by its reciprocal. So you get x plus 5, quantity squared, 21. Okay? Now what?
Would you FOIL on the x plus 5?
Oh, God, no, that'd be awful. You can, but it's just square root. Yeah. Yep. Yep, square root both sides. I put a square root over an equal, which means what do I have to have on the one side? Plus minus. So, you get x plus 5 is plus minus square root of 21. I didn't even bother to try and simplify that because I know that nothing's going to work. Okay? Now, with the 1/3, I multiplied by the reciprocal, got rid of it. How do I move that positive 5? Subtract. Now, here's the other part of math etiquette. When you solve these equations, you've got radicals in it. Your whole number stuff always goes in front. That would be your answer. Negative 5 plus or minus root 21. Okay? That's what that would look like. You don't tack it on in the back end because sometimes your radical symbol might look longer, and you might think, oh, it's plus or minus square root of 21 minus 5. Oh, it's plus or minus square root of 16. Oh, it's plus or minus 4. And then you're wrong. And then you fall into a black hole of death. Okay. Good. I always look on the bright side, don't I? Always look on the bright side of life. Oops, okay. So, what about this then? Five times the quantity x minus 1 squared equals negative 50. What do you do first?
Divide by 5.
Divide by 5. Good. So I get x minus 1 quantity squared is negative 10. Now what do I do?
FOIL.
I square. FOIL? Why would you FOIL? Jeez. I'm taking a square root over an equal. I got to put a plus minus. But then, what are two numbers you multiply together that are the same to give you a negative? You don't, right? So, you guys have had this problem now, and what would you always say? Incorrect, or you'd say no solution, right?
Wrong.
There's a solution, and it's complex. Sorry, I saw you flipping. Okay. It's a complex solution now. What happens here, are you guys okay with what are called primes and composites?
I've never heard of composite number.
A composite number is two numbers that are two numbers that multiply together. Like 10 is a composite of 2 and 5.
Oh, so it's like 10 or whatever 10 is times I.
You're getting there. You're a little ahead of it though. Okay. Correct. So prime numbers, as we know, are only divisible by 1 and itself. Composites are made up of anything. Now, when you did those square root things a little bit ago, the reason why I wanted to show you that idea of the square root of 24 is that in and of itself was a composite, but it was a composite of roots. So it was root 4, root 6, and you simplified it to being 2 root 6. You were able to find that. Well, you guys have always been taught if you got a negative root, no solution. Which isn't wrong, because there isn't a 0 there. Now, go back to your Algebra 1 remembering when you did quadratic formula. Remember when you did what was called the discriminant, the stuff underneath the radical? If it was negative, you guys stopped and said no solution. The curve was still there. The curve was still there. It just so happened that that curve didn't cross the axis. It had roots. They were just imaginary. We just didn't talk about that then. So what happens here is I can break this into into 10 times negative 1 is negative 10. Everybody okay with that? And now this idea of the square root of negative 1, this is the imaginary number, I. So, hold on. The way that textbooks generally write the letter I for imaginary is usually a lowercase cursive I. I was taught whenever I wrote lowercase, just a singular letter of an I or a T, that it had a tail. That's just how I write it. Your textbook writes it. It has that little bit of a wavy I. I don't even know what it looks like, but whatever. You'll get used to it. That just means I. So the square root of negative 1 simplifies to equal the imaginary value, imaginary number. Which means now, your whole world is opened up to twice as many maths.
Yeah.
Okay? So back to this one here. So we have x minus 1 is, well, I just said a second ago that the square root of negative 10, we can't simplify the root 10, but I can take the negative 1 out. The square root of negative 1 is I. So now this root here becomes plus or minus I root 10. And then how do I move that negative 1? How about I add it? So x would equal, and again, the whole number goes up front, 1 plus or minus I root 10. The idea here is, guys, that when you are working through and solving, and you have a negative root, you can now solve them. It is a complex number, it is a complex solution, because the imaginary root is there. Okay? Curves that are parabolas don't have to cross the x-axis. We've graphed some like that already. We've seen them. Those guys didn't have a root. It wasn't factorable. We didn't have any real roots, but yet the curve still exists. Where it's crossing and getting its own zeros are in the imaginary root. Okay? So what happens then, like I said, we get into this thing called complex numbers. What's the square root of negative 1? Shut up. Staring at me.
What is
All right. So he's like, say something.
Yes.
2x squared plus 3 is negative 13. All right? What do you do first? Subtract 3. Good. So I subtract 3 just like we went before. So I have 2x squared negative 16. Now what?
5 by 2.
5 by 2. X squared is now negative 8. Now what?
X equals I root 8.
Okay, all right. Now you're right, but I'm taking the square root over an equal sign, so it's going to be a plus minus. Now, what was the square root of 8? 8. It was 2 root 2, right? So the only thing that's different now, instead of 2 root 2, it's 2I root 2. The order in which we write these is if you've got, remember this is the same thing as square root of 1 times, negative 1 times the square root of 8. We know the square root of 8 is 2 root 2, and this is I. The math etiquette says whole number before imaginary before root. I didn't see that coming. The invisible number? Imaginary. No, but sorry, go ahead. The imaginary number is what? Oh, the square root of negative 1. That's yeah, you always take out, you can multiply anything by negative 1. Yeah. The square root of negative 1 is always I. That's the rule. Okay. Square root of negative 1 is always I. Not bad, is it? It's etiquette. Yeah, it's just the proper etiquette, it's the proper form. And I2 is still I times 2. It's like when you have 2x. Do you put x2? Same idea. If you treat that I value when you're writing it out, like you would a variable. Does that make sense? What do you do now? Okay. Same idea. Same idea here, guys. First thing we're going to do in this case, there's nothing out in front of the radical or in front of the parentheses. All I got to do is just square root it. So if I square root right away, I get x minus 1 is plus or minus square root of negative 7. Negative 7 breaks into negative 1 and 7. Can you simplify square root of 7? No, what's the square root of negative 1 then? So now I know that this simplifies to be plus or minus I root 7. And what do I do with that minus 1 to move it over? So x equals 1 plus I root 7.
Wait. Okay. When you have negative, you put the I and then
Yep. And you treat it the exact same way.
So what is this like x minus 1?
Hold up. What is it? All right, go on. What did you say? X minus 1?
So you have to add one from like the left side, but you also give one when you square root it. You get
Oh, all right. What I think I know what you mean. So if you had like x minus 2 equal plus or minus the square root of 9.
Yeah.
Okay. Well, what's the square root of 9? 3. So you get x equals 2 plus or minus 3. What are your answers? 5, negative 1. But in all honesty, if you have it like this, I'm fine with that. Okay. Now, if this was a negative 9. I can't do 5 and 3. I can't do.
Yeah, that's what I meant.
You cannot combine it because treat the I value like you would like the variable. It's like combining like terms. And we're gonna do more of that style tomorrow. Today it's just a lot of equations. Okay? A lot of equations. Let me get this. That's something folder. Where's my? Let me show you the problems I got for tomorrow. Or not today. I'm sorry. What day is today? I don't know what day it is. I picked out a couple of them. I forgot to write it down. So you give me 1 second. I'll have it all posted here. I got both PDF files up on the calendar for today because it is in 2 different sections. I think there's a total of maybe 8 problems, maybe 9. It's nothing too crazy. Once it loads. Come on. PDFs are up. All right, those PDFs are up. Those are the sets. There's, I think I got 4 in each one of them, 4 and 5, so it's maybe a total of 9. So, not a big deal. Remember, square root of -1 is always. That's fine. No problem. No problem. That's good. That's good. That's good. What's up?